So we have one customer here in the United States, the Echo Group, that are making emergency lights for safety vehicles. And they were able to use SolidWorks Plastic Simulation to consolidate one assembly from many parts down to a single part using the injection molding process. Now what that allowed them to do was not just consolidate all the parts into one part, but eliminate a bunch of very costly molds that they would had to produce otherwise if they were going to produce all those individual parts. And those molds can be very expensive. They might cost anywhere from tens of thousands to hundreds of thousands of dollars for just one mold. So by being able to use the simulation to consolidate the number of molds resulted in a tremendous cost savings for them. So the one thing that I would want people to know about SolidWorks Plastics is that anyone involved in the design or the manufacture of injection molded plastic parts or injection molds, or even people running injection molding machines, can use SolidWorks Plastics today and get value out of it. So you don't have to be an advanced simulation or a CAE user or anything like that. And in fact, if you can use SolidWorks Plastics just to determine the right gate location on your part, you might avoid upwards of 80% of the potential problems that you would have downstream in the manufacturing process. So even a novice user using SolidWorks Plastics just to determine the best gate location can realize tremendous value out of the product. One of the primary reasons that injection molding is used as a manufacturing process is because it's a very high volume manufacturing process. So normally when you're looking at injection molding, you're considering making hundreds of thousands, if not millions of parts per year out of one mold. Injection molding cycle times are relatively fast, anywhere from 3 to 5 seconds on the low end for overall cycle time, up to maybe 40 to 60 seconds maximum cycle times. So basically, you're producing a lot of parts, a high volume of parts in a very short period of time. So even though the cost of one individual part may not be all that much, just pennies on a dollar, because you're producing so many so quickly, the numbers get big in a hurry. Injection molds can be very expensive. They can cost anywhere from tens of thousands to hundreds of thousands to over $1 million for one mold. So you can imagine that by using SolidWorks Plastic Simulation, if you could save just 5% on your overall cycle time, or if you could avoid just one round of costly and time-consuming mold rework, you're going to realize an incredibly quick return on investment on the investment made in SolidWorks Plastic Simulation software. And then over time, because the injection molding process is such a high volume manufacturing process, if you're saving, let's say, 5% on cycle time, every time that mold cycles and produces a part or multiple parts from you, your cost savings can also grow very quickly, exponentially in a hurry. So it's not uncommon for a customer to be able to realize a savings of tens of thousands, if not hundreds of thousands of dollars on just one mold using SolidWorks Simulation on just that one project. The number one rule to follow is to try to maintain a uniform wall thickness. So let's say your part is on average 2.5 millimeters thick. You like to try to maintain that 2.5 millimeter wall thickness throughout your entire part. In other words, what you want to avoid is going from 2.5 millimeters down to 1 millimeter, maybe up to 3 millimeters. That would be a really bad thing. And that's because the more that you can maintain a uniform wall thickness, the more that will lead to uniform stress distributions in your molded part. It leads to more uniform shrinkage, and ultimately it leads to a part which is much less likely to warp out of shape when you take it out of the mold. One of the most common mistakes made when designing plastic parts is for plastic parts that are meant to replace a metal part that's already in production. And oftentimes what we see happen is that the designers will design the plastic part with the same specifications as the metal part. Now, the metal parts, because they're typically machined, you can have varying wall thicknesses without any problems. It's very easy to machine, varying wall thicknesses in a metal part. In an injection molded plastic part, that's not the case. And that's why the number one rule to follow when you're designing a plastic part is to maintain uniform wall thickness. So when you're going from a metal to plastic replacement, what you want to do is take that metal part design and core out the thick areas, so that so it results in a part that has uniform wall thickness over most of the part surface.